Arduino for complete noobs, and we have for this evening's sessions, Amitai Schler, a complete noob to the world of Arduino.
It's a me.
We also have off to the side my cat, who desperately, desperately wants to assist with this session. So let me. I just realized I'm probably. Well, we aren't going to use the command line tonight, so I don't need to worry about that. All right, so let's start off about talking what our goals are and what we're going to do. So, if you look in the upper right hand corner of the screen, you see sort of a lot of. It looks like a lot of junk up there. But one of the things you see, and let me get a pointer, which looks suspiciously like a pencil that I'm pulling out of my desk. So what I'm pointing to right there, that little black blob with some silver dots next to it, that is a AT Tiny 85. It is a dirt cheap little microprocessor, and it can't do a lot, but for a lot of things we're going to use this for, we don't need it to do a lot. And they're so cheap you can't buy just one. So this, let me see if I can get past all my cabling. This here is the smallest unit I could buy, which was a little plastic bag with 6 processors, and the things on the left-hand side of the picture there are little sockets that you plug it into. You don't wire this directly into the board. You wire the socket into the board, and then you plug your little chip into the socket. If you buy these in bulk, they cost about $1.50. I didn't pay much more than that buying them like this. They're just super cheap, and they'll do a lot. And down here, it doesn't show up on camera right now because it's not lit, but at the end of that pointer it's actually resting right on top of a red LED. And I think tonight's goal is to make that fade in and fade out, sort of like eyes blinking. And this is to a point. If somebody likes to make their own Halloween animatronics instead of spending a lot of money for something really cheap at a chain or cheaply made at a chain store, you can make your own. You can make it do what you want. And the basics of making a light fade on and off are no different than the basics of making a servo move, so that you can have motion in your animatronics. Something else that's on that board is really hard to see because of the way the camera is. This little blob right here that I'm pointing to, that's a resistor. And if you foolishly try to run an LED without a resistor, you have a really good chance of letting the magic smoke out of the LED. And for those not in the know, magic smoke powers all electronic devices. And as soon as the magic smoke escapes, the device never works again.
That's right. That's one thing as a noob that I do know about hardware, which is that it's really important that the smoke stay inside.
Yes. Nobody likes the smoke to get out. All right. And so normally for most people just starting out, you'd use something like the Arduino IDE. And because we're doing an online sharing session, the Arduino IDE doesn't have that capability. So instead, we're going to use Visual Studio Code. And one of the great things about Visual Studio Code, a lot of people at Microsoft are geeks that play with hardware. And so they made the Arduino plugin for Visual Studio Code. So if you have VS Code and you have the Arduino IDE, you can install this plugin, and you have all the features of the Arduino IDE inside of Visual Studio Code, which is great. We've got to do a little setup now. We have to tell, when we're generating code, we have to tell it what kind of code we have. In fact, let's put that off for a little bit. Let's get some code first.
Cool.
Have you ever written a VS Code or an Arduino program before? A sketch?
No. So let me give my background about what makes me such a noob here. I've programmed before a fair amount. In fact, I often like to pair program and mob program with other people and help them with whatever they're doing. but it also means I don't have a lot of domain expertise in any particular thing. My domain expertise is the pairing and the mobbing and programming in general. And so I'm used to sort of, I don't know, dilettanting in someone else's problem space. And I never managed to dilettante my way into understanding anything about hardware. So I did get a Raspberry Pi and I did run that one time. And I think I did a programming workshop with the idea of we develop on the Mac and then we deploy to this so-called target, even though it is a general purpose computer. And that was cool. And that's as far as I got with that. I did also buy an Arduino, I don't know, like 5, 6, 7 years ago. I'm pretty sure I have it, but I never used it. And now I'm several thousand miles away from it. So I've heard of one. I have the vague sense that it's a thing that people program, and I just have no idea how.
Yeah. So well, this will be the night to learn that maybe. All right. So I'll tell you what. I'm going to get the project set up here, and an Arduino project is really really easy to set up. I'm gonna create a new file, and since I'm trying to make this wink like eyes, my ultimate goal is I'm going to stick this inside of one of those fake pumpkins that you can buy at the craft store and carve eyes out of it. And these lights will go on and they'll make the eyes light up.
Nice.
I have some faith that it'll look pretty cool. So we're going to call it Winky. And Arduino projects end with .ino. I'm not sure why they chose that, but they did. And then an Arduino project has two functions. Oh, you know what? I'm going to let you take the wheel, and I will strong pair you here. Okay?
Oh, nice. All right, let me make sure my live share is live sharing.
You
Okay,
are.
yeah,
You
I
are.
see
All
a
right.
winky dot I know.
All right. So for those who aren't familiar, live or strong pairing is where the person who knows the domain or knows the project, uh, they're the one. They are not able to communicate their ideas except through the hands of the person who doesn't know the project. In this case, I'm the one who knows the project and the domain, and Amatai is the one who's trying to learn it. So I'm not going to touch the keyboard again for a
Yeah,
while.
and a note about how that works is that when the ideas are coming from Clay, the strong style navigator, and I'll be the driver, is how that's called. Um, he and I, in some way, have to negotiate what level to speak at for me to do the thing that he meant. And so some of that is for him just to be able to verbalize what it is that he means in the first place. But a lot of it is about if we didn't know each other at all, he would probably start by saying, type VOID and then a space and so on and so forth. Or he might try the other end of it. He might say, I need two new functions, which is what he was starting to say when he was typing, and see if I understand that level of abstraction, and then figure out what he can say in the most parsimonious way to get me to type the thing that he's thinking. And that depends on what he's thinking, but also depends on what I know and how we can communicate that. So we're going to negotiate that pretty quickly because we do have some background together, but he has to be able to say something in a way that I can type. So let's go for that. Did you see my testing 1, 2, 3 on your screen?
I did. It showed up and it's in the stream, so life is good.
Okay. All right.
In
So navigate me, please.
yes, in fact, just before we get to that, let me. Uh, I'm gonna go and actually make sure that I'm gonna get on the stream because we want to make sure there might be people out there with questions, and if you are watching the stream and you do
Yes.
have questions, please ask them in the chat. We're somewhere between 10 seconds and a minute behind, so it may take a little bit before we see your question and we can answer it, but we will try to answer your question. So let me pull that up. All right. There's nobody in the chat yet, so we're fine. So, all right. So yeah, we need two void functions. One of them is called setup and one of them is called loop.
Whoops. I have some stuff selected.
And
Okay, let's try
neither
that
of them,
again. So we need a setup.
yep, and neither of them take arguments.
So I say that like so,
Yes.
or just blank.
You can do
Okay.
either one. I've taken to putting the void in there to make it explicit.
And is this your brace style of choice?
Yes, it is.
Okay,
I
cool. We don't have to argue about that.
Yeah, exactly. Nobody wants to. I think if you hit save, I think it'll just format it in my brace style of choice.
Oh, nice. Okay.
Okay, so apparently my brace styling
Oh,
choice is like that. I'll be honest,
I accept.
I'm not that fussy about it as long as it's fairly consistent. I'm good. Okay.
Yep. 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 Yep.
And the other function we need is loop, and I don't know that we need uh, to go much deeper than that.
Should I define that now?
Uh, yeah, go ahead and do that. Uh,
Okay.
because we're just spiking this, so normally if Amatai and I were working together, we would be writing tests about what we're going to do. But tonight we're doing what we call spiking, where we're just trying stuff out to see what works. Uh, if we were doing this work for a client, this code would never get submitted. But I think that's a great way to go learning about Arduino is just try some stuff out. And I
Cool.
need to do so. The next thing we're going to need to do is initialize some pins to tell to tell this little microcontroller this pin is output. Now, the cunning thing that I didn't think of was that I didn't remember the pin out for this, and I don't know which pin that's actually connected to.
Huh. How
Uh,
many pins are there in the pin space?
there are 6 addressable pins. There's 8 pins total. One is ground and one is power. So we are on the right now we are connected with a
Ah,
pin called PB2,
okay.
and that has I don't know. So I'm looking for a feature called PWM, which is pulse width modulation, and that is not available on pin 2. So I'm going to make a quick hardware change, and then we're going to
Okay.
do the right thing. Uh, okay. So all right. So yeah, pulse width modulation. Ah, excellent, Amatai. But question marks asking me to fill in some details for him. Uh,
Whenever is the right time.
yeah. Well, let's talk about that. So we want to make this fade in. Rather, we don't want to just turn it on and turn it off, because eyes. We're gonna have a pumpkin mounted on a wall or stuck in some bushes or something, and we kind of want it to look sinister. We want those to glow and come up like that. If it just blinks on, that doesn't look that sinister. It might be startling, but it won't be sinister.
Mm-hmm.
So if we make it come up, we'll use something called pulse width modulation, and we basically tell the processor turn this pin on and off really fast, and we'll give it a number for how fast we want it to turn off, and I think it's between 1 and 1023. But whatever it is, that range of numbers is all about uh, how much of the time should I be on. So if the total range is 1023, uh, say you want it to be mostly on, you might set it at 900 or something like that. Uh,
Mm-hmm. Okay.
this seems like a clever time for me to go look up how that
Yeah.
works.
Cool. So
so
if I understood let me not distract you, but I think I have a vague idea that we would move that over the course of a second or a couple seconds from more like 0 to more like 1023,
yeah,
and it would fade in like that.
yep, that's exactly what we would do.
Okay.
And okay, so the first thing we have to do before we get going there, uh, the number is smaller. But anyway, um, okay, we need to tell the computer that that's an output pin, and so we do all that. That's a setup function where we say this is what role this pin is going to serve, and so the function to do that is in the setup function, and it's called pin mode. And excuse me. All right. Uh, that particular pin that we're interested in is Arduino pin 1. So you can just put a 1. And this is a trick that you run into when you're dealing with these things. Arduino pin numbers are different than hardware pin numbers. That's hardware pin 6. But it's also. But the internal reference that I would use if I wasn't using Arduino, that's also considered pin 1. So in this case, yep, and I might write hardware pin 6 on that.
Yeah.
There's an
Okay.
order, for those who aren't aware, there's an order on these devices. And I guess we aren't zoomed in enough on it to really see it. But the numbers run from 1 up to the maximum number of pins on the device. And it starts at what's considered the upper left and runs down the left side and then back up the right side from the bottom. So it's pin mode, it's one word, and the M is capitalized.
That's the trick.
All right.
I was getting squiggly and getting nervous about it.
Yeah, and it takes 2 arguments. The first one is the pin number, and we want pin 1. And the second number inside the parens. That argument is the word output in capital letters. Excellent. And so that says that pin 1 wants some output. All right, now everything else we're going to do, we do it down in the loop function. And this loop function it runs through the loop function once. When the loop function ends, it'll just run through it again, and it'll keep doing that until the power is pulled. So the first thing we want to do, we need to, I think we should probably do a for loop. We need to power it up. Do you remember how to do a for loop in C?
I think so.
All right.
So int,
yep.
Or what do we need?
An int will be fine. Yep. And we'll go all the way up to 255. All right. And the thing we do in here is analog. The function is called analog write. And just like the pin mode, the capitalization. And it's the pin number. Let me confirm this. While I look at the fine manual here. Yeah. The first argument's the pin number. The second number is the value that we want. So I guess we'll have it be I. So the pin number is 1.
So the pin is that 1.
Yep.
And the value is?
Just I.
And then let's see how autocomplete or quick fix works in Visual Studio Code. Did I hit return? Is that what I wanted to do?
Oh, that's curious. Okay.
Maybe.
Let me hover over it and see what's grumpy.
Undeclared identifier?
Oh, okay. So what's going on is it doesn't really know about... We haven't done the right includes for the C parser to know what to do. And we could do that, but we don't really need to, and it probably won't cause trouble, but it theoretically could. There's normally a file called arduino.h that you would include, but because this is a .ino, it's actually going to get wrapped in all of that. I think it's a capital A.
Okay.
It's complicated, and if you're not going to use the Arduino IDE, you don't usually use the IDE. You don't usually use the Arduino abstractions because it makes life harder.
Okay. So some of these squiggles just are, and you'll be able to tell the difference.
And I think... So this processor isn't super fast, but we do want to do a little bit of delay. So there's just a function called delay. And the value you give it is in milliseconds. I think we can get this at 10 milliseconds between, and it'll be visible for how much it comes up. All right. We want to try it and see if our little light... Well, let's make it go down, too.
Okay.
So it's the same function, except that the eye goes in the reverse direction.
I'm going to see if I can keyboard select this for loop. No, not like that. Okay, I'm going to use my mouse,
Yeah, I was gonna
filled with great regrets.
say. Visual Studio Code works better with the mouse.
And so now we'll go the other way.
Yeah. 255, stay greater than 0. And subtract instead of add. My other assistant has joined us.
Something needs killing or has been killed or will soon be killed.
Oh, he wants attention. He napped his whole day away, so he didn't get attention during the day. I think he was feeling a little under the weather. He's old and got bad arthritis. We had heavy storms move through today, so he probably didn't feel the greatest.
Poor guy.
He will continue to serenade us. All right. That's
Lovely.
Aiden, by the way, for those who are not familiar with my associates.
he's aiding us with our programming.
Aiden is not going to get quieter. He's been heard all over the world. Teams in Mexico got to hear him this week. They heard him in Moline.
Nice. And now they're hearing him in Germany and whoever's watching.
Yeah, I mean, he just gets all over.
An accomplished cat.
Yep. Okay, so I think that might be enough to try. And that's not bad for 25 minutes in. So I have to do a little bit of magic here. So when you're working with an Arduino, there's things you have to set because different Arduinos have different requirements. So this defaulted to using our Arduino Nano, and it doesn't actually default to that, but I use Arduino Nanos a lot, so that's where it opens up. And this is an AT Tiny. There we go, AT Tiny 85. And when you first install the Arduino tools, the AT Tiny is not initially included, but it's easy to go find the instructions for setting it up. Okay, so we're setting it to be AT Tiny. There we go. I knew it had to come up more. Okay, so there's three options here. The AT Tiny 25, 45, and 85. I use the 85. The other two aren't really easy to get on the commercial market. They're out there, but I don't usually see them. And the other thing we have to do is select our programmer. And if you look up in the camera, you see this this red stick.
I thought that was going to be, this is sort of a joke. I thought when I heard that phrase, select your programmer, I thought that was going to be your last chance to work with somebody else besides me, such as your cat.
Tonight, the role of Amatai
But it's
will be played by my cat.
That's right. But so you're saying that the programmer is the thing that sends the program to the device.
Yeah, exactly.
Okay.
So if you've used an Arduino before, usually you can just hook up a USB cable to them and program them. This device is so tiny, there's no room for a USB port on it. And so this uses a different interface called SPI. And what that means isn't really important right now. The important thing for us is it means you have to use one of these little sticks. They're like $15 on Amazon, and they're actually pretty nice. They're easier to work with than the USB cables. There's less fiddling. And you just plug the chip right into that, and you can program it, and it's got... you can kind of see them. There's these little row of pins out near the edge. You plug into that, plug it into your test circuit, and see how it's working. And then once you're happy with it, you can just build your circuit with its own little socket, pop all your programmed chips right into there. So that's the other reason I like the AT Tiny is they were designed for, I'm going to make half a dozen of these things to stick around my house on Halloween, and so it's really easy to program them all without fiddling with a lot of cables. Anyway, that was a long excursion for saying, hey, look, I picked all this stuff. And so now we have to pick a programmer. And that programmer is called the USB Tiny ISP. So that's picked. Let me close that. And we've closed our board, and Amatai is taking nice notes. Yeah, and if you're, this is a really good note to take. If you're working with embedded, there's always some kind of programmer besides the person at the keyboard typing the code. I actually think the terms are separate in French, which maybe makes it a little easier. Which might be why Montreal's got a lot more embedded work than Ann Arbor does.
Intéressant.
Oui. The my I've got another chip I use that you have to buy a special programmer from the company, but the programmer itself is really nice, and there's less fiddling with that than anything I've ever worked with. Okay, so I think we might be ready to push this to the board. Now, is this... Oh, that doesn't do the thing I hoped it did. It used to be that there was a little button right along the bottom here that I could say a go to the board. I don't think that's there, so we have to go to the command palette. And there's a whole bunch of Arduino commands there. And there'll be something here about upload using programmer. That's the really important one. Okay, and my question here is a serial port hasn't been specified. I don't want to select a serial port because this doesn't use a serial port. So I'm hoping that it understands when I asked for a USB Tiny ISP that it will do the right thing.
How did you know the USB Tiny ISP out of the many dozens is the one that you want?
I knew that because I played around with the Arduino tool itself before this to figure that out. And I've been working on, for those who've been following this this live stream, I've been working on something called Stormlight, not to be confused with the game, for the last 2 months, and that's also using a Tiny 85. So I had to learn all that stuff for Stormlight. Okay, so I said to program it, to upload the program, but it didn't do anything. So let's try that again. I don't know. It could be, so upload using programmer. I do not want to select a serial port. I think by saying I don't want to select a serial port, that's its way of saying, it's assuming that I'm saying go away and don't bother me anymore. So let's try, there was a different upload. So we'll type Arduino and upload. Oh, well, that's fun. It's not going to do it. Now, the really funny thing about this is it calls the exact same program as if it was using a serial port. It just says instead of serial, you tell it, instead of sending the serial port, you send USB Tiny ISP. All right.
It's like a pseudo serial port.
It's not even a pseudo serial port. It's a different device. It's a USB device, and the computer knows about it. And if you tell, the program's called AVR Dude that does the uploading. And if you tell AVR Dude, yeah. If you tell AVR Dude,
I think I've seen that around before. Yeah, okay.
Yeah. If you tell AVR Dude to use a USB Tiny ISP, it is totally cool with it. It knows what that is. It finds it on the USB bus and sends the data out that way. All right. So this might be the point where we do something a little bit different here on the stream. I am going to copy all of the code itself. I'll leave Amatai's notes here. And I'm going to switch to the Arduino IDE.
Mm-hmm.
So there's what my desktop...
Because
it's got
that one for sure knows how to send something to an Arduino.
I literally did it 5 minutes before we came on just to make sure. Actually, I did it more like 45 minutes before we came on because if I was wrong about knowing how it worked, I wanted to be clear there. Now I'm going to move the camera view just a little bit, just so you can see what's going on. So I don't know how clear this comes through for folks in the stream. This might not be the great illustration we're hoping for. It looks like it's not super clear, but down here at the bottom of my screen, it says ATtiny on DevTTY USB 0. So we have to fix that up here. We have to say that's not what it's on. In fact, it knows that it's on a USB Tiny ISP. All right. So while it says TTY USB 0 down here, that's not where it is. Oh, gee, I wonder if that would work in... Well, let's push the code and keep an eye in the camera view. Keep an eye on that spot right there.
Mm.
Look at that. It's fading on and off. We
Cool.
got what we were looking for. Now, on the camera, the fading action isn't as obvious, but here in person, it's really clear that it's getting brighter and paler. So that's exactly the behavior we want. Unfortunately, these webcams aren't as good about catching some of those subtle lighting details. When you point it at a direct light source, it tends to wash out right away. In fact, you can't see it.
I can see it changing. It's not smooth over the entire gradation the way that it probably is for you, but I can see that it's doing that.
Yeah. Okay, I want to try something. I want to go back over here and let's see if TTY USB 0 is one of my options. Oh, it is not. Let's put that in and see what it says. Oh, it's not happy about that answer at all. Okay, so...
It just didn't count, yeah.
Yeah. All right, so a downside of using the Arduino IDE, or of using Visual Studio Code, is it doesn't know about how to deal with an ATtiny 85. That's not a big deal if you want to get started with Arduino. There are other little controllers you can use. They cost a little bit more money, but not a lot. So I'm going to show you. This here is an Arduino Nano. And if you buy 10 of them, I bought a bag of 10 for $33. And they literally just come in a paper envelope.
What are those ones?
It's an Arduino Nano. So it's a lot more powerful than the chip down there. It's more powerful than the computer I learned to program on. It has a lot more memory.
What was the computer you learned to program on?
I learned on a VIC-20 is what I owned. I took some classes on a TRS-80. But TRS-80s cost kind of a bit of money back when those were the things that came out. And I had to pay for this out of my allowance. So I saved up a whole summer and bought a VIC-20 because that's what I had at the end of the summer. It was about the price of a VIC-20. And I learned a lot out of it. So I think it was money pretty well invested.
And now we're here.
And now I can buy a sack of computers for $30.
I know, right?
Every last one.
So I was just observing this earlier today. Like Raspberry Pi is something probably everybody has heard of. It's so popular, people have heard of it. Arduino, not as many, but still a lot. And then there's zillions of other little tiny boards that you can program that you can do like this with. That I'm sure there's almost uncountably many of them, and I'm sure that I've never heard of most of them and never will. There's just so many different cheap computing devices that you could get like this.
Oh yeah, and
that we never dreamed of when we were kids.
Yeah, that Raspberry Pi is $35, and it's significant. It's running Unix, and it's significantly more power than most personal PCs that people had.
5-10 years ago.
Well, I would say into the 90s at least.
I mean, they're general purpose computers. When I did a workshop with the Raspberry Pi, I pretended that it was an embedded device because that was a good learning experience. But you can just SSH into the thing and program right on the thing. It's a computer.
I have written beautiful visual applications on them. They
Nice.
fully support lovely visual applications. Just to give you an idea of how far things have come, that is an ESP8266. That has Wi-Fi built into it. We're actually working on the first this might be the first computer I owned that had Wi-Fi. I'm trying to remember if I had
I
Wi-Fi.
see a question in the Twitch from
Oh,
Jeeves
excellent.
Zero.
uh, so Jeeves, we are working on what's going to be a Halloween decoration, and that little LED that's fading on and off is going to maybe have its timing adjusted, um, so that it stays on for a little while and then stays off for a little while. And we're going to stick that in the jack o' lantern, and the jack o' lantern is going to have eyes that light up. I get in a normal year, I get 300 to 500 kids coming to my door, so Halloween's a big deal here. And anytime I can do something cool like this, I really enjoy it. Um, and one of the nice things, especially something like this, is when it gets night, very little is required to make uh, something believable. I stick two of these looking out from underneath my truck. It looks like something with glowing eyes is watching you from under my truck. It's really great. I'll stick some in some bushes and maybe some trees. Uh, at some point, I'll do a live build of the hardware for this, maybe of a jack o' lantern. But another thing you can do is you can stick this in a toilet paper tube or a short length of PVC, and you drill a couple of holes in it for eyes, and you can stick a battery and this little computer in there, throw it in the bushes, and it just sits there and does its thing. And uh, I've used something similar to that before. Little kids just love it. They're walking by and suddenly they see glowing eyes looking at them out of the bushes. That's a huge hit. uh, and Jeeves
Sounds like Jeeves has let some magic smoke out before.
it does sound like Jeeves is a magic smoke escapee, or has seen the magic smoke escape. So uh, yeah, when we get into that, we'll talk about the build more. And for a different DIY Halloween project, one of the items on my bill of materials was a bag of LEDs that they already had leads wired onto them. They had about 8 inches worth of lead, and they had a resistor built in there. We talked earlier about the importance of the resistor. Uh, they want to run off 9 to 12 volts, and so you couldn't run that off an Arduino. So we'll stick a transistor in to control them, and we'll talk about that when we're doing the live build. So anyway, I think we just want to make some modifications to this now. I wish we could do this in the live share so that uh, you could type remotely on it. There's not a
Well,
good way for it to do it here.
let's compensate for it. Tell me what functionality you're going to add, and then
Yeah.
how you're going to do it, and I'll ask you if I'm confused by something.
Okay. So I think the next thing we want to do is we don't want the eyes to come on and then just go right off again. Although actually that little pulsating thing is kind of interesting. It could be kind of sinister, but I kind of wanted to wait for a little while. Maybe let's have them stay on for 30 seconds or something like that. Uh, and so what I would just
And so
want to,
for that, you would do a delay of 30 times 1,000,
yeah, what a lovely
because
way
those are
of
milliseconds.
expressing that is 30 seconds. And then once it goes off, I want it to stay off for a little while too. Maybe it stays off for a minute.
So long enough to make you wonder, did I see that?
Right, and it just becomes a jack o' lantern at that point. But then you know, they go away and the next kid comes up and the eyes light up. So let's see what happens when we do that. Okay, so it's out there. Our light is actually, I believe it's sitting on right now.
So is it true you just added a couple lines in between the two different for loops, and then did something to send it to the Arduino? The IDE here, this is the Arduino IDE.
Yes.
It compiles and or presumably cross compiles and then sends a program over the USB just like that.
Yeah. It's kind of a nice. There we go. It just dimmed down to almost nothing. Oh, you know what? I don't think we ever took it all the way down. So it's sitting there with a very minimalist glow to it. That's funny. And we never saw that in the earlier cycle. Okay, so it's going to
Jeeves
sit like
says,
that
what
for
are
me.
you guys using to communicate with ESP? A server like Heroku, or you're making it a server itself
Yeah, so Jeeves,
to communicate with
actually
ESP?
we're working with a AT Tiny 85, and so we are communicating with this. Uh, this red stick here is a uh, it's a programmer for the AT Tiny series, and I shouldn't be touching that with my conductive lead. I swear I saw sparks. Uh, this right here that I'm touching, that's the actual chip. That's the AT Tiny 85. It is a really, really tiny Arduino chip. They only run at 1 megahertz. They're not real fast. But we don't need real fast. We're making a light fade on and off very casually. And I see that it's staying at a really low level for a while. And right now in this testing mode, I think these are too long. But also, because I want to get rid of that glow out there. When we get to this point, I want to do a digital write and set it low. And low is the equivalent of off in the digital world.
hmm
Uh,
So what is the state that it's in just before we added that, where it's dim? What is it? Is it a qualitative difference from off or a quantitative difference from off?
so, yeah, it is a quantitative difference from off. So we're on a PWM circuit. You know how I said we're asking for a percentage of how often it's on? The scale is between 0 and
hmm
255 for how often it's on or off. Because we're using it in PWM mode, it is still going to stay a little bit on. Uh, it's just a different mode of operation. So I think by switching to a digital write
Uh,
and explicitly force it low here, it won't try to push current out there. So
uh-huh. And then do you need to bring it back high at the beginning of the loop, or does the analog write early on take care of that?
the analog write should take care of that right up there. But
Okay.
let's let's do the same thing. Let's set it high there. And I'm finding waiting for a full minute is driving me nuts. It's long enough that I'm worried like we broke something.
Right. That's a good deployment setting, but not a good development setting.
Yeah. Okay, there we go. It came on. It's going to stay on for probably
Oh, Jeeves has a tip for us.
10 seconds. Uh, let's try it. Okay, the digital write trick
Cool.
worked. It did just turn itself completely out. But I like Jeeves' answer for this. Let's try it. Oh, that won't work because one high. Oh no, high is like 255, so that might work. Analog write one high, and low is 0. So let's see what happens when we do that. Yeah, this difference in debugging times versus production times is worth keeping in mind.
hmm
All right, we've just sent it out. Oh, with that analog write low, it
I do still see it. Yeah.
yeah. Wait, no,
Oh.
that might have been a remnant of something. It's all the way out.
hmm
It's thinking. It's thinking. It's coming back up.
This looks. Oh no, I
Oh,
don't have an explanation for why
high
it
is
takes a little
one.
while.
High is one. That's what our problem is.
Mm. So we get stuck in that almost off state.
Yeah. So we do need to do a digital write
So that one should stay
high.
there.
Yeah, I'm gonna keep the symmetry.
Because the semantics of what you're saying is an on-off. That is digital.
Yeah.
It's not a range. It does make sense. At least to read it, it makes sense. I don't understand the nuances.
Yeah, there's some magic going on behind the scenes with the Arduino library. That's what's happening there. Okay, it's fully
Can the
off of the.
IDE show like the value of the high macro
I
in an
don't
easy way?
know if it can. I don't think. Yeah, I don't think it can.
You just know that it's one from previous experience.
Yeah, I've rooted around in those header files a little bit. All right, it just came up
Okay.
quite nicely. Got a good steady state light. But I mean, this is always something you have to be aware of with hardware too. That like what works in theory doesn't always work in practice. You have to see how it's really going to behave on the hardware.
Hmm.
I think we've kind of got.
Presumably, it could even depend from one pin to another.
Yeah. Oh, absolutely. Now this device only has analog pins, uh, but it does not. Does not have PWM on all pins. The original pin
Hmm.
that I had it on was not an analog capable pin, or it wasn't a PWM capable pin. All of the well, no. Okay, the pinout I'm looking at right now is a SparkFun pinout, and it's not quite complete. Um, there are four There are four analog readable pins on this device, though. But so let's make some of these values random. Like how long it stays on should be random, and how long it stays off should be random.
Hmm.
And the first thing we have
Within
to
a, yeah.
yeah, within a
Okay.
reasonable time frame. Um, I have to go look up the random function. There's a random seed, and random seed takes a value, and there's a sort of a standard way to do this. So we do random seed analog read 1, and we're using one. Well, no, that's grounded. I don't want to do that. That'll actually stay. So let's do it 0. So what we're doing there, analog read reads from an analog capable pin, and or, but there's nothing connected to it. So it's just picking up random signals out of the air. And because I'm in a basement, those values won't be all that random. But if we're in the Forge, which is in the 7th floor of a building downtown Ann Arbor, and right under a cell phone tower, the values are really random up there. It's just picking up random radio signals out of the air and reading them. It's a digital value between 0 and 255, or 0 and 1024. It's picking numbers anyway. Okay, and we want this number to be. So we're saying 10 seconds, but we want this to be random. Looks like the random function maybe takes an argument too, and I don't understand that. Oh, random takes a maximum value. Okay, so let's make it.
Minimum is 0.
Yeah, it can take a minimum and a max. So let's do that. Let's give it a minimum and a max. Let's say it should stay on for at least 5 seconds. It probably shouldn't stay on for longer than 60 seconds. And then it should stay off for somewhere between. Oops. Random. Stay off for at least 20 seconds, but could stay off for maybe a couple of minutes. So let's make it 120 seconds. All right, let's see how that flies. Didn't tell me to get wrecked, so that's always a good sign. All right, it's staying on for a little while. That would have been really helpful for us to know exactly how long it was going to decide to stay on. But uh,
Right.
this, so like with the regular, most Arduinos, you have a serial port, you can send data back. It's really helpful for debugging things like this. These are so tiny they do not have a serial port on them. They have an SPI bus, and you could communicate over that, but it's a different type of communication. It's kind of non-trivial to send data over it. You have to kind of have to know what you're doing. It's not horrible. I didn't feel like I had to know too much. All right, it just went off. It's going to stay off for a little while. Oh, and it's back on. It wasn't on for long, was it? You always worry when it comes on and then goes right off. Did I let the magic smoke out?
Yeah. It's just a short interval.
Yeah. We did say it could be on for as little as 5 seconds, so.
Yeah. You can blink in about 5 seconds.
Yeah. Now it's not going to come on again until I look away. We're talking about something else. Of course, there's a lot of dead
Right.
air. There's a lot of dead air here.
A watched random never. Can't think of the verb now.
Yes,
Something
but
like that.
yes, a watched random interval never ends.
Yes, there you go.
All right, and we're back up. We're coming up. And we're holding for a little bit. I think that's going to look pretty sharp. the LEDs, those 9-volt LEDs that I use are a lot brighter than this. I think it'll look pretty sharp. I stick that in a pumpkin. All right, I think that's a wrap on this one. We've come to just about an hour. So if anybody has any more questions, this is going up on YouTube. You'll probably be seeing this on YouTube if you didn't watch the stream live. Feel free to put it into the comments on YouTube. I do get notified about comments, and we'll try to answer them there. And if you have questions that need a more detailed answer, we'll probably try to answer it on a following stream. So thanks for tuning in, everybody. And Amatai, you have anything, closing remarks you wanted to make?
No, just thanks for having me. And it's cool to see that you can so quickly get a physical thing to do a physical thing.
Yeah.
It helps to know a lot, but you can quickly get a thing to do a thing. And that's really cool.
Yeah, and for this, I mean, what do we have? Like 4 functions? Oh, we've got one. Yeah, I think there's 5 functions total in here that you had to know about. And they're all documented on the Arduino website. Digital write and pin mode, those are like the first 2 functions anybody learns about. So, because the first example they always give you is make the light blink on and off.
I figured, yeah.
Not in our gradual way, but in a very, hey, I'm on and now I'm not on. And so
Yep.
you know about those functions already, and the rest, not that hard to look up. And analog write usually is one of the next ones. Anyway,
Nice.
I want to thank everybody who tuned in to watch us fool around with a little LED, and we will see everybody next week. Good night.